Hello, we're going to continue with the product law of exponents today, also known as the property of exponents for multiplication. But before we do, let's go back and review what we've done already. So we started with the identity property, which looks like this. It says any number, any base that we raise to the first power equals that base. So some examples might be if I took any number, we'll start with 9, and we raised it to the first power, that would be 9. Which means any base, for instance, it could be any variable, we'll use a. If we raised a to the first power, we would have a. Now conversely, if we are given a number that did not have a power on it, if we're given the number 12, well, we could write it as 12 to the first power, and sometimes that comes in handy when we're using the product law and quotient law, etc. So the next property we talked about is if you have any base, we'll use x as a base, and you raise it to the 0 power, it's going to equal 1, no matter what base we use, whether it's a positive or negative base. If we had, for instance, the base of 5, and we raised it to the 0 power, that would be 1. And when we get to the quotient law, we're going to prove why it is 1, because when you first learn this law, it does not make a lot of sense unless you see it once we prove it to you with the quotient law, which will be tomorrow's lesson. Also, if we took a negative base, if we had negative 3 and we raised it to the 0 power, it would also be positive 1. That one's confusing sometimes, but it's still positive 1. Which would bring us to any variable. Well, you choose the variable m. If we raise it to the 0 power, no matter what that base was, it would be 1. So here's the final law or property that we talked about in our last lesson, and we're going to write it again, how they'd write it as a rule. We would start with, again, we're going to call the base x. If we had a number that was raised to the nth power times, that's where the word product comes in, a number raised to the m power, we could take the two powers, n plus m, and that would be, we could combine them into one expression instead of having two separate bases with powers. We could combine them into one, so it helps us simplify. So let's use numbers to make that a little bit more clear. So if we started with 6 to the second power and we multiplied that times 6 to the third power, then we could write this as still the same base. As long as it's the same base, this law works. We would add the two exponents. And so we would get 6 raised to the 5th power. It would also work with negative numbers. If we had negative 2 raised to the 5th power times negative 2 raised to the 4th power, we could write that as negative 2, and then we'd add 5 plus 4, or 2 powers, and we would get negative 2 raised to the 9th power. We could also use this rule with many variables. With variables, we could also use it with many of the same bases. It wouldn't just have to be 2 of them. For instance, if we had, let's make it 10 to the 4th power times 10 to the 2nd power times 10. We could write that as base is 10, and we have 4 plus 2, and you might notice that the last 10 doesn't have a power, so we could write 1 there, plus 1, and that would equal 10 to the 7th power. So let's now move on to the lesson. You can find this in the paper that was passed out last week, and it is page 3 and 4. So far, we've worked with expressions in exponential form with one common base, the big number. Now let's extend the product law to expressions that have multiple bases. For the following examples, we're first going to write the expression in factored or expanded form, and then we're going to use the product law. So if we work on the first expression. I see 4a. So 4a together means 4 times a. So I'm going to write this out the long way. I'm going to expand each one of those. So 4 times a. Then I see this times dot, and this expression means 4 times a to the third power, and a to the third power is a times a times a. So if I want to, which we'd prefer to, I'm going to rearrange those. I'm going to gather up, I'm going to call it like terms, but I'm going to gather up the two same bases, the two numbers. They don't have to necessarily be the same when we do this. And I'm going to rewrite all of the a's that I see so it's clear how many I have. So let's check. I wrote 4 and 1, 2, 3, 4. Yes. So if we're going to simplify this, 4 times 4, the best way to write that would be 16. And then a times a times a times a, well, I simplify that to a to the fourth. So we'd rather write this expression as 16a to the fourth. That's the simplest way we can express this. If we use the product law, so let's compare that. Instead of extending it, I have a 4 here, there's one of them, and I have a 4 here, and remember, everything's being multiplied, so I'm allowed to use this product law. So I could add the 4 and 4 to get 4 to the second power. Then I could take a, and I see a to the first power and a to the third power. So I'm going to put a times dot and separate those. A, and I see the first power, and our law says we can add the exponents on the same bases. You're noticing that I have 1 4 and 1 4. I can add those together because those exponents are above the 4, and I can only add the exponents above a when it's on the base of a. So now that would be a to the fourth power. Whoops. And so I can actually extend this further. 4 to the second power, since they're numbers, I could say that's 16 times a to the fourth. I could just write it the high school way, side by side, instead of the times dot, and we have gotten the same answer. We've come up with the same answer. The expanded form might make it a little bit more clear to our brain. We can actually physically count the parts and pieces, where the product law is much quicker. So let's try this again. Okay, the expanded form, remember that 6y to the fourth power means 6 times y to the fourth power. So I'm going to break this down into smaller pieces this time, make it a little bit easier to see this if you're confused. So that's what the first expression means. Then I'm going to write this times dot, and now I'm going to break down the second expression. 2y to the third power means 2 times y to the third power. So maybe this way it might be a little bit easier to see all the parts. So I'm going to gather up. I see that this is a regular number and another regular number, so I'm going to write 6 times 2, and then I see a group of y's. Well, I have 1, 2, 3, 4 y's here, and then I have 1, 2, 3 y's here. So now in order to simplify this, I'm going to go ahead and gather up my 6 times 2, and I can simplify that by making it 12, and then I'm going to count all of the y's. 1, 2, 3, 4, 5, 6, 7, and since they're being multiplied, I can write this side by side, so y to the 7th power. That's the final answer. So now let's look at it when we use it, how we would use this using the product law. When we start out, we have 6, and if I want to gather up the other number, it's a different base. So I'm not allowed, I can't use the product rule because this base and this base are not the same, like I did in the example above. But I can take my y's, because this base and this base are the same. I can take the 4 above the first y and add it to the 4 above the second y, because if you recall, everything's being multiplied, so I can kind of move things around. The commutative property says as everything is being multiplied, then you're allowed to move because order doesn't matter. So to simplify this, 6 times 2 would again be 12 times y, and then I'd add the exponents, which would be 7, and when they're side by side, that means the same thing as our times dot, means multiply, so we get the same answer. So what I'd like you to do now is, would you please try to expand this expression, and then would you try to use the product law in this expression, and when you're done, replay the video. We should have gotten negative 21 times y to the 7th. Let's move on to the next page. Please go ahead and try this first example and replay the video when you're done. Okay, as you can see, I tried to color code the expanded form so you know where the parts came from, and there was only one number base, so you could have put a 1 in front of the second expression m, but it really wasn't needed. However, that would have helped you. You could have put 12 times 1 when you're expanding it. For instance, you could have done this if you found it helpful, but I think it might have distracted. So you're noticing the next group is just written instead of the times dot. Side by side means multiply. So please go ahead and write the expanded form and then use the product law again and replay the video when you're done. In this particular example, maybe you can see the benefits of learning the law of exponents. We had to write 7 n's plus the one that we were given in the first expression, the first term, and so when you count them, you have 8 of them. So both ways we're going to get 24 times n to the 8th power. Now the next two examples are just a continuation. They might look a little bit more intimidating, but it's just a continuation of this. We just now have more variables and more exponents to work with, so a little bit of a challenge. So let's go through the first one together. We're going to start again. I'm going to gather up the numbers. Everything is being multiplied. Remember, everything is being multiplied. So this 9 and this 2 are both regular numbers. They're being multiplied. Now I'm going to go gather up all of the a's that I see. I see 1a here, so that's times a. And then I see 4 a's here, so a times a times a times a. That's 4 here and 1 here. And then I'm going to go after the b's. I see 2 b's here, so times b times b. Have those covered. And then here's another b times b. So 9 times 2 is going to give me 18. And I can see 1, 2, 3, 4, 5 a's, so a to the 5th power. And then b, I can see 1, 2, 3, 4, so b to the 4th power. So all of that now becomes one term, 18 times a to the 5th power times b to the 4th power. So let's see what that would look like if we didn't go the expanded way. We would gather up we'd still gather up the numbers, okay, the coefficients, and now we're going to be able to use the law. I'm going to work with a, and remember this a by itself is a to the 1st power, and then I see this group of a's, and that's a to the 4th power. Now I'm going to go with the b's, and b's, I have b to the 2nd power here, and b to the 2nd power here. Everything's being multiplied, which means that as long as they have the same base, I can add the exponents. So 9 times 2 is 18. A, the base of a, 1 plus 4 would be a to the 5th, and the base of b, 2 plus 2 would be 4. We get exactly the same answer. So I'd love for you to try this using the last example. Replay the video when you're done, please. Okay, and as you can see, we get the same answer, and both are legitimate uses of that, but hopefully you're starting to become more comfortable by using the product law. Thanks for listening. See you next lesson.